Good day, everyone. So, today we shall be looking at questions and answers on photoelectric effect. Okay, so let's dive into this. Example 1 says the work function of a metal is 4.65 electron volts, and the metal is illuminated with a radiation of 6.86 electron volts. What is the kinetic energy of the electron ejected from the surface of the metal? Right? So, how do we solve this problem? As our usual practice, we write out our parameters one after the other. Let's go over the question again. The work function of a metal is this value. So work function is W naught by symbol. So W naught is 4.65 electron volt. And then we are told that the metal radiate energy of this value. So the energy radiated is 6.86 electron volt. And we are made to calculate the kinetic energy of the electron. So the kinetic energy is the unknown. And by formula, kinetic energy is equal to energy radiated minus one function. And then energy radiated is 6.86 electron volt. Okay, we substitute it here. Then minus the work function, which is 4.65 electron volt. And that will give us 2.21 electron volt. Simple, right? Yeah. So let's take another example. Example 2 says the work function of a metal is 8.6 times 10 raised to the power minus 19 joules. Calculate the wavelength of each threshold frequency, given that the speed of light in vacuum is 3 times 10 to the power 8 meters per second, and the Planck constant is 6.6 times 10 raised to the power minus 34 joules second. Right, so we write our parameters again. We are given work function as well, yeah? So W naught is 8.6 times 10 raised to the power minus 19 joule. We are made to calculate wavelength of the wavelength of the radiation now. That's our lambda naught. Okay, the lambda naught is unknown, but we are given the speed of light, which is c now by symbol, to be 3 times 10 to the power 8 per second. So that's c. And we are also given Planck constant, which is h. H is 6.6 times 10 to the power minus 34 joules second. So to determine our wavelength, we use the formula. This wavelength naught means threshold wavelength. So threshold wavelength equals, we are determining threshold wavelength because it's coming from a threshold frequency. So threshold wavelength is equals to product of Planck constant and speed of light over work function, right? So Planck constant is 6.6 times 10 to the power minus 34 multiplied by speed of light, which is 3 times 10 to the power 8, all divided by work function, that is 8.6 times 10 to the power minus 19. When we simplify this using our calculator or our law of indices, we have our wavelength to be 2.3 times 10 to the power minus 7 meters. Right? So we move on to the third example. Here it says, calculate the frequency of the photons whose energy is required to eject a surface electron with the kinetic energy of 1.9 times 10 to the power minus 16 electron volt if the work function is 1.33 times 10 to the power minus 16 electron volt. Given that 1 electron volt equals 1.6 times 10 to the power minus 19 joule, and Planck constant, which is our H, is 6.6 times 10 to the power minus 34 joules second. Okay, seems ambiguous but very simple. All right, so we go straight to the question again to write our parameters. So we have to calculate the frequency. So the F is unknown, and this photon has energy. Okay, has the energy. Okay, and then it also has the kinetic it also has the kinetic energy, and the kinetic energy happens to be 1.9 times 10 to the power 16 electron volts. So we are given kinetic energy. We are also given the work function to be this value. So it's written out W naught equal to this value. And then we are given Planck constant, which is H, to be this value as well. So to calculate our frequency by formula, frequency is equal to the sum of the kinetic energy and the work function all divided by Planck constant. So kinetic energy is beginning to be this value here, 1.9 times 10 to the power 16 electron volts. So written out plus the work function, which is 1.33 times 10 to the power 16 electron volts, is written out here. So all divided by Planck constant, that's 6.6 times 10 to the power minus 34. So now if we factorize this, we find out that 10 to the power minus 16 electron volt is a common factor here. So it has been brought out to be 10 to the power minus 16 electron volt. It is here and it is here as well. So that's the common factor. Then we now add up 1.9 and 1.33. So 1.9 plus 1.33 will give us 3.23. Then times the factor, the common factor, which is 10 to the power minus 16 electron volt. Now all divided by the Planck constant, this value. Okay. Now I expected to convert this electron volt to joule. That's why we are given the conversion formula here. So 1 electron volt is this value. So here we replace 1 electron volt, this electron volt, with 1.6 times 10 to the power 19. Okay, and then all divided by the Planck constant. So when we simplify all of these, the frequency will now be 7.83 times 10 to the power minus 2 Hertz. All right. Okay, so we move on to the next one. Next example here, it says cesium has a work function of 3 times 10 to the power minus 19 joule. The maximum energy of liberated electron when it is eliminated by light of frequency 6.7 times 10 to the power minus 14 Hertz is what? Okay, now let's write our parameters again. The work function is given, so W naught is our work function. That's 3 times 10 to the power minus 19 joule. And we are made to calculate the maximum energy. Maximum energy is the same as the kinetic energy, right? So kinetic energy is unknown, but we are given a frequency of 6.7 times 10 to the power 14 Hertz. So by formula, kinetic energy equals the product of Planck constant and frequency minus work function. All right. So Planck constant is a constant value, which is 6.6 times 10 to the power minus 34. Okay. Even though it's not given in this question, we are meant to know these constants by heart. Okay. So the value is 6.6 times 10 to the power minus 34. That's the value of H multiplied by frequency, which is 6.7 times 10 to the power times 10 to the power 14, then minus the work function, which is 3 times 10 to the power 19, and everything will be equals to, when we simplify this, we have our kinetic energy to be equal to 1.422 times 10 to the power minus 19 joule. Right, so we go straight to the last example for today. And here we go. It says a photoemissive surface has a threshold frequency of 4.0 times 10 to the power 14 Hertz. If the surface is illuminated by light of frequency 5.0 times 10 to the power 15 Hertz, calculate the threshold wavelength, the work function, the kinetic energy of the emitted photoelectron. Given that the speed of light, which is c, is 3.0 times 10 to the power 8 meter per second, and the Planck constant, which is our h, to be 6.63 times 10 to the power minus 34 joule second. Okay, so let's take out our parameters in this question again. Here we are told that the photoemissive surface has this threshold frequency, that's our F naught. So F naught is 4.0 times 10 to the power 14 Hertz. Now, if the surface is limited by a light of frequency, now if another frequency is used, which is now our f again, with 5.0 times 10 to the power 15, we are made to calculate the threshold wavelength. So the threshold wavelength by formula is speed of light over threshold frequency. Speed of light is constant, that's c, so 3 times 10 to the power 8 all over threshold frequency, which is given 4.0 times 10 to the power 14. And when we simplify this, we have our threshold wavelength to be 7.46 times 10 to the power 7 meters. Second question said we should calculate the work function. Work function is equals to the product of Planck constant and threshold frequency. So Planck constant is given to be 6.63 times 10 to the power minus 34. So we put it here, multiplied by the threshold frequency, which is 4.0 times 10 to the power 14. So when we simplify all of these, our work function will be 2.67 times 10 to the power minus 19 joule. So the third question says we should calculate the kinetic energy of the emitted photon electron. So kinetic energy still remain product of Planck constant and frequency minus work function. So Planck constant is 6.6 times 10 to the power minus 34 multiplied by the frequency, which is 5.0 times 10 to the power 15. Then minus the work function. The work function is obtained in the second question here, which is 2.67 times 10 to the power minus 19 joule. So we bring it down here to minus 2.67 times 10 to the power minus 19. And when we simplify this, our work function will be 3.048 times 10 to the power minus 18 joules. All right? Yeah, so this is where we shall be drawing the curtain for today. Thank you for listening and bye for now.